In this video, we will talk about the derivatives from the first principles, which is the definition of the derivatives. On this graph, we are given a point A and point B, where the coordinate of A is x and f of x. And we're going to increase it by h on the x coordinate. So the point B has a coordinate of x plus h and f of x plus h. Now we're going to find the slope of AB. Slope of AB is a change in y over change in x. So f of x plus h minus f of x over x plus h minus x, which is on the right side. Simplifying the denominator, we can cancel out the x's on both ends, and we're just left with h on the denominator. H is the distance between A and B. So as the distance gets smaller and smaller, eventually as h approaches 0, the line AB becomes a tangent to a curve. So think of it as these 2 points getting closer and closer together, the line that contains A and B will become just a tangent at A. So here again, as limit h goes to 0 of the slope is equal to the gradient of the tangent. So that's the definition of the derivatives. Use the definition of derivative to find the gradient function of f of x is equal to x squared. What the question is suggesting is find the gradient function, the slope function that generates all of the slopes on f of x. So using the definition of the limit, first we need to calculate f of x plus h. F of x plus h on f of x is equal to x squared. For every x, we are going to replace that x with x plus h. So we have x plus h squared comes out to be x squared plus 2xh plus h squared. So derivative is equal to limit as h goes to 0 of f of x. What we just found is x squared plus 2xh plus h squared minus x squared all over h. Limit as h goes to 0, x squares will cancel out, and you're left with 2xh plus h squared. So they have h's in common, so you can factor out the h. So you're left with 2x plus h over h. Cancel out the h, we're left with the limit as h goes to 0 of 2x plus h. Plug in the 0 for the h in here, we get 2x. So derivative of x squared is equal to 2x. Find the instantaneous rate of change in f of x is equal to x squared plus 2x at x is equal to 5. Instantaneous rate of change, that means gradient of the tangent line. In other words, slope of a tangent. So using the definition of the limit, which is derivative is equal to limit as h goes to 0 of f of x plus h minus f of x all over h. So here we have, first evaluate what f of x plus h is. In this case, we are going to replace all of the x values with x plus h. So we have x plus h squared plus 2x plus h. So we have x squared plus 2xh plus h squared plus 2x plus 2h. So let's plug that value in to limit as h goes to 0 of f of x plus h that we just found, x squared plus 2xh plus h squared plus 2x plus 2h minus f of x, which is x squared plus 2x all over h. We have x squared and minus x squared, so that will cancel out. We will also be able to cancel out the 2x and minus 2x. So we are left with limit of h goes to 0, 2xh plus h squared plus 2h all over h. So again, we will be able to factor out the h on the numerator. So 2x plus h plus 2 all over h. So h's will cancel out. And once you plug in h for 0, we are left with 2x plus 2. So derivative of the f of x is equal to 2x plus 2. In order to find the slope of a tangent at x equals to 5, we simply plug it in, and we get 10 plus 2, which is going to be 12. 12 is the slope of the tangent at x equals to 5.